So in this segment, I'll be mainly telling you how to solve the logarithmic equations. Okay. Before I start solving this equation, we need to recall that if you have log with any base of 1, that is equal to 0. If you have log to the base a, that is equal to 1. And then if you have log to the base ax plus log to the base ay, like this is the product rule. So you have log to the base a xy. And similarly, if you have log to the base ax minus log to the base ay, so that will be log to the base a x over y. Okay? Now,
Yes,
starting
sir.
with question number 1a. So you have log to the base 5x plus log to the base 5, 3. So you see that I can write it as log to the base 5, 3x, and that is equal to log to the base 5, 30. Now there is another rule over here that if you have, let's say, log to the base ax, that is equal to log to the base ay. So this would imply that your x is equal to y. So similarly, in this situation, you have your 3x that is equal to 30. So your x is equal to 10. Okay? Now look at this
ठीक है सर.
2a. Now in this 2a, you see that this is log to the base 10 here, log to the base 10 here, and there is a subtraction sign. So we can write it as log to the base 10, and this is 2x plus 9 over 5. Okay. Now, instead of this 1, can I multiply this 1 with the log to the base 10, 10? Right? So since that is like using this rule over here, log to the base a, that is 1. So I can just write here log to the base 10, 10. Okay. Now we can say that this part is equal to this 10. So this is 2x plus 9 over 5. That is equal to 10. So you can solve this. This is 2x plus 9 equal to 50. 2x equal to 41 and x is 20.5. That is the solution to this. Okay.
Okay, sir.
Similarly, if you look at this third question now, in this third question, you can see that there is um, log to the base 2x. Okay. I'll be doing the C part. Okay. So you have 2 log to the base 3x minus log to the base 3x minus 2, and that is equal to 2. So before you apply the product or the quotient rule, you shouldn't be having any coefficient with these logarithmic expressions. So you need to shift this power onto it. So this would become log to the base 3x squared minus log to the base 3x minus 2, and that is equal to 2. Now, while we have shifted this 2 onto this x, I can write log to the base 3, 3 over here. So that all these terms, they have a logarithm with the base 3. Now this is going to be log to the base 3, and there is a minus between them. This is x squared over x minus 2. That is log to the, now I'll be shifting this 2 onto this. This is log to the base 3 and 3 squared, which makes it 9. Okay, so now this part is going to be equal to this part. So this x squared over x minus 2, that is equal to 9. So this is going to be x squared equal to 9x minus 18. So you solve this x squared minus 9x plus 18. So that is going to be 6 3s are 18. This is x minus 6 into x minus 3. So your x is 6 and then your x is 3. Acha, Walid, when you have found the values of x, you have to check them if both of these values are acceptable, or any one of them has to be rejected or both of them have to be rejected. Look at this. This is log to the base 3x minus 2 over here. If you put your x3 over here, this will become log to the base 3 of minus 1. Now, is it a defined logarithm? Remember I told you when there is log to the base a of b, first of all, the base cannot be 1. The base has to be positive. And the one whose log is being found, that has to be positive as well. So if you put your x as 3 into this, see if you write both of these answers, you will get 1 mark deducted. Okay? So if you put x equal to 3, so this equation is going to be undefined. So this is going to be rejected. So the only correct value of x is going to be x equal to 6. Okay?
Okay, sir.
And similarly, if I take you to the, let's say, question number 4, maybe. In question number 5, you see that you will have to go for some substitutions. Like you see here, you will have to substitute this log to the base 2x as maybe y. So this will become y square minus 8y plus 15 equal to 0. So first you will find the value of y, and then you will get that x from there, okay? If I solve this quickly for you, this will become y minus y equal to 5 and y equal to 3. So you will put that log to the base 2x equal to 5. So this x is 2 raised to power 5, or this x is going to be 2 raised to power 3. Okay? Should I do this question with detail from this fifth question? Hmm?
Yes, sir.
Okay, let me do this with detail. Now this is a question on basically on substitution. You see this is 5a. It says log to the base 2x whole square and minus 8 log to the base 2x plus 15, that is equal to 0. Now, if it was not the whole square and the power was just on x, you could have shifted that power back to the coefficient. But this is log to the base 2x, a square, like the same thing is having a square here, and this is without the square. So you can start by saying, okay, let this log to the base 2x is equal to y. So this becomes y square minus 8y plus 15 equal to 0. So you will solve this equation first to get your y. So I can do that middle term breaking, y square minus 3y minus 5y plus 15. So this is going to be y minus 3 into y minus 5 equal to 0. So I have y equal to 3 and y equal to 5. Now I'll be putting this y back as log to the base 2x, that is equal to 3, and log to the base 2x, that is equal to 5. Okay? So now this x is going to be 2 cubed, which is going to be equal to 8. And this x is going to be 2 raised to power 5, which is going to be uh, 32. So that is how you solve the parts from question number 5. Okay? So I give you 10 minutes to try some questions from here, and then we move to the next segment.